Yeah, you are audible. Am I audible?
Yes, it's audible.
I'll share my screen, sir.
Yes, sir. Good.
Is my presentation visible?
Yes, sir.
Good afternoon, everybody. Hello.
Recording in progress. Yes, sir.
Good afternoon, everybody. I am Professor Suresh Mane, Principal at Dr. D.Y. Patil Pratishthan's College of Engineering, Kolhapur in Maharashtra. And my paper ID is 122. And we are speaking on sustainable transport using new generation engines as well as fuels. An experimental study of emissions with biodiesel as a fuel in RCCI engine. So as per the given agenda, we will go through the abstract, introduction, objectives, proposed method, experimental setup, results as well as we will show the conclusion and emphasis. To start with, we are talking about sustainable fuel for sustainable transport. As of today, mostly transport is carried out through petrol and diesel, which are not sustainable in nature because their fossil fuels are finite in nature. We are talking about a sustainable fuel, that is biodiesel, which is made of plant oil seeds. And secondly, we are talking about right now a lot of CI engine, that is diesel engines are used for transport, especially heavy load transports, but trucks, buses and all, even railway engines. But we are talking about RCCI engine, which is a new generation engine, which is still the research is going on. Commercial production has not started, but it is a improvement on the current CI engine, so that it uses the technology of CI engine as well as petrol fuel, biofuel it is basically. It leads to low temperature combustion basically, and due to low temperature combustion the NOx production in the engine is low. That is the funda of this work basically. And for this actually these CI engines are used in agriculture and transport also. So we are used lot of sensors because mechanical engineering, without the sensor we can't gauge the temperature, pressure, fluid flow, etc. And we have got a lot of sensors embedded so that we can get the data, and the data has been analyzed. We, and this engine what we have taken an engine which can be changed slightly from compression ratio 16 is to 1 to 17 is to 1 and 18 is to 1. So there are three, we are studying on three different compression ratio. But the fuel we have taken is B20, that is biodiesel 20, that is 20% of biodiesel blended with 80% of petroleum diesel. And we have seen that due to the increase in load and the increase in compression ratio, the temperature of the combustion increase and the NOx emissions increase. And when this NOx, there is a trade-off. When the NOx increases, the carbon monoxide and the hydrocarbon emissions, HC emissions, are reduced. But due to this work, we have seen that can be reduced up to 75%, hydrocarbon can be reduced up to 60%, and carbon monoxide can be reduced up to 40%. So we are talking about carbon neutral mobility for net zero options, because India is going for net zero, and we are committed in the next 70 years we will be going for net zero. And this study is basically about the technical feasibility of a RCC engine. This study has been supported by Shivaji University Kolhapur through that Diamond Jubilee Research Grant. And with this grant, we have manufactured biodiesel, as well as we have changed the existing diesel engine to work as a RCC engine. I will be showing it in the subsequent slide. This RCCI combustion reactivity controlled compression ignition engine is an advanced combustion technology that blends features of diesel engine and gasoline petrol engine, to achieve higher thermal efficiency as well as to reduce the emissions. It operates by compressing the uniform fuel air mixture, that is what we do in a CI engine, that is diesel engine, until it auto ignites, thus reducing the peak temperature of the combustion, that is called, we call it a low temperature combustion here, and thus minimizing the formation of NOx. I'd like to add that NOx is produced in an engine at a higher temperature, say 1800 degrees centigrade and above, and we are trying to reduce the temperature of combustion in the engine below that, and also it reduces the particulate emission matters. So this also caters to the affordable and clean energy, which is SDG 7. Industry innovation and infrastructure, a new engine is being coming up, that is SDG 9, as well as climate action, that is comes under SDG. 13. So the properties of biodiesel and petrol diesel are quite similar, but we can see that the density is slightly high, biodiesel density high, and even the flash point of the fuel is high. But one thing is the fuel value, that is calorific value of the fuel is low, because biodiesel has got around 15 to 20% of oxygen in that, and that is why it burns well but produces lower heat. For this work, we have taken karanja oil, that is called as Pongamia pinnata. It is a non-edible feedstock. And by the standard process of trans-esterification, we have prepared biodiesel. And then this biodiesel we have blended in 80-20 ratio to produce B20. The engine we have taken is a standard Kirloskar TV1 engine, where we can vary the compression ratio from 12:1 to 18:1. The engine has got standard specifications, and here we are used, because we want to control the various parameters, we have used an open source ECU which is programmable basically. And this is that we used to when we are injecting the gasoline, that is petrol, in the port, we have taken three different timings: 3 milliseconds, 4 milliseconds, and 5 milliseconds.